Hello everyone. In last video, we wish to answer this question. How many times will athlete have to change his direction of motion to complete one round? To complete one round of those tracks, which are of different shapes, we have considered the how many times he needs to change the direction or how many times he needs to take the turn. That was the question. We will answer this. Basic assumptions we have done: the athlete runs at a uniform speed. So we have assumed that athlete, he was running at a constant speed or uniform speed. And second, athlete changes his direction of motion at corners of the track to keep himself on the track. Obvious, to be in the motion, to be on the track, whenever the corner will come, the athlete will change his direction. Different shapes we have considered: rectangular track, then hexagonal track, and then regular octagonal shaped track. We know the directions east, west, north, and south. Let us consider that athlete, he was initially at the corner A and he is heading towards west direction. Now he has started running. He is westing towards west direction. From A to D journey, as he is traveling in a straight path, no need to change the direction. But once he will reach to the corner D, to be in the motion, he needs to change the direction. Again, from D to C, he will travel, but once he will reach to the corner C, there he needs to change the direction. Again, from traveling or running from C to B, as a straight path is there, no need to change direction. But once he will reach to the position B or corner B, he needs to change direction. Again, from B to A, while running, straight path is there, so no need to change direction. But again, once he will come back to the position A, and he has to be in the initial position. In initial position, he was heading towards west direction. So again, after coming to the A corner, he needs to change the direction, right? So for rectangular track, total 1, 2, 3, 4, 4 times the athlete has turned, or 4 times he has changed his direction. Same thing if you consider for hexagonal track, he start journey from A. At corner B, he will change the direction. At corner C, at corner D, at corner E, at corner F. Again, to be in the position or to be in the initial position, he will take the turn at point A. Similarly, if you consider for regular octagonal shaped track, he will start hexagonal track, as there are 6 number of times he has changed the direction. If you consider for regular octagonal shape, from A he has start, then at B corner he will change, C corner he will change, D corner he will change, E will change, F he will change, G he will change, H he will change the direction, and again to be in original position at A corner he will change. So total 8 number of times he has changed the direction or he has taken the turn. What is the observation here? As the number of sides of a track increases, athlete has to take turns more and more often. Obvious. Here the logic is the number of turns are equal to the number of sides of a track. Here the rectangular track has 4 sides, so he has changed the direction 4 times, or 4 number of times he has taken the turns. For hexagonal track, there are 6 number of sides, so 6 times he has changed direction. For regular octagonal shape, there are 8 sides, so 8 number of times he has changed the direction. So this is the logic. Now if you think of as increasing the number of sides of a track indefinitely, means the number of sides of a track, if they are infinite, then how many times he needs to take the turn? Obvious mathematically answer to this is he has to take the turn infinite number of times. As the number of sides of a track, the number of turns will be infinite. Obvious. What does it mean actually? The length of each sides of a track will decrease to a point. As the number of sides of a track increasing, as the number of sides of a tracks are increasing and it reach to the infinite, means the length of this track, it is decreasing and decreasing and decreasing, and one point of time they will become a points, as here shown here, right? So it will turn into points, and that one individual point, it indicates the side of a track, right? And if you think collectively, all these points what they indicate? Single point, it indicates one track, one side of a track, right? But length of each side of track has decreased to a point, and collectively these all points come together and they will create a shape of a track, which is nothing but shape of circle. So shape of a track approaches to a shape of a circle. All these points I'm saying, all these points collectively, they will create a shape, circular shape. So what we can say from all this is, if the athlete moves with the velocity of a constant magnitude along circular path, only change in his velocity is due to the change in direction of the motion. See here, whatever the change in velocity for that athlete, it is not because of change in magnitude, because he has, as we have assumed here, his speed is constant. He is running with a constant speed or uniform speed, but still there is change in the velocity. So that change in velocity is because of change in direction, right? So like this, so many times he has changed his direction, infinite times he has changed his direction to be on that circular track. Here, for the regular octagonal shape, he has changed the direction 8 times, for hexagon 6 times, for a rectangle 4 times. But as this circular shape track, it is made of infinite number of sides, so he will take infinite number of turns. Just for our understanding, here we have shown 1 2 3 4 5 5 turns we have shown, but like this infinite number of turns will be there, right? But because of those turns, there is a change in velocity, and that change in velocity is not because of change in magnitude of that speed or magnitude of the velocity, it is because of change in direction, right? So on a circular path, he will change the velocity by changing the direction. So such kind of motion, we say such kind of motion as uniform circular motion or accelerated motion also. Thank you.